Okay guys, so I'm gonna give you the notes on similar figures. So figures that are similar, and remember we use this little squiggly. Sorry, that was really bad. Have the same shape, but not necessarily the same size. To prove figures are similar, their corresponding angles must be congruent, and their corresponding sides must be proportional. Okay, so we're going to identify the pairs of congruent angles and the proportional sides in the following figure. So angle A matches up with angle H. Angle B would match up. You could match up angle B with either angle J or angle L. I chose to match up angle B with angle J. In this case, it could also match up with angle L. I just chose to go in alphabetical order. Angle K would match up with angle C. And angle L would then match up with angle D. That means that side AB would be similar to side HJ. AD to HL. JK to BC. And KL to CD. So a similarity statement can be written to show that the polygons are similar. So write a similarity statement for the figures above. So one example could be A, B, C, D. So if we went A, B, C, D for the first one, we would have to go H, J, K, L. And a really easy way to do that is to match up the angles. Since we went A, B, C, D, we would have to go H, J, K, L. A similarity ratio is a ratio that compares the numbers or the measurements of the corresponding sides of the two similar polygons. The ratio is the same order as the similarity statement. Okay, write a similarity ratio for the figures above. So AB over HJ is equal to AD over HL, which is equal to JK over BC, which is equal to KL over CD. So basically what I did is I took the sides from up here and I put them in fraction form. And I set them all equal because we know since they're proportional, because they're similar, they're gonna be equal. They're proportional. Okay, determine if each pair of polygons are similar. If so, write the similarity statement and the similarity ratio. So in A, we've got 4 right angles, so the angles are good. Now all we have to do is check the sides. So we go 10 over 16. And 10 over 16 is 5 over 8, I believe. So we just need to check whether 35 over 50 would give us that same result. So 35 over 50, if we divide by 5, that would give us 7 over 10, which is not going to give us the same fraction. 5 over 8 is not equal to 7 over 10, so these are not similar. So now on to the triangles. Let's first check the angles. So let's figure out what this angle is right here. We can easily figure that out from subtracting from 180. We can take 180 minus 90 plus 20. And we find out that this angle is 70 degrees. We can do the same thing over here. And we find out that this angle is 10 degrees. So these are not similar because their angles are not equal. Okay, then we have some questions, discussion. Two similar polygons have a similarity ratio of 1 to 1. What can you say about the two polygons? So if they have a similarity ratio and the numbers are equal, then those two shapes are congruent. Are all congruent figures similar? And our answer is yes. They're just a very, very specific kind of similar. Can similar figures be congruent? And yes, they can be, but not all are. It's kind of like the discussion we had. Not all cars are Chevys, but all Chevys are cars, or vehicles, not cars. So scrolling down, this was one of your worksheets for the week. I know some of you have already completed it. And then I'm scrolling down one more, and I'm gonna do these notes. And then this right here is your other worksheet for the week. So in case you don't need the notes, but you wanted to know the worksheet, that's your other worksheet for the week. So I'm going to continue the notes here. So now we're moving on to similar triangles. There are 3 ways you can prove triangles similar. So now we're focusing on triangles without having to use all the sides and angles. Angle similarity, if 2 angles of one triangle are congruent. I'm just going to use a little congruent symbol. To 2 corresponding angles of another triangle, then we know enough to say that the triangles are similar. Because we also know that the third one has to be congruent as well. Okay, so side similarity. If the 3 sides of one triangle are proportional. So say this one's 2, this one's 3, and this one's 5. And then this one would be 4, this one would be 6, and this one would be 10. We know enough. Side, angle, side. If 2 sides are proportional, and the included angle, which means, remember when we did side, angle, side with proofs, that means the sandwiched angle is congruent, then we know enough. So say we know this angle and then this side is 2, and this side is 3, this side is 4, and this side is 6. See how we have a similarity ratio of 1/2, and we know the sandwiched angle? We can say that this is SAS. SAS, we say SAS, oh gosh, I'm so sorry guys. My finger hit. We say SAS similarity. SSS similarity. Angle, angle, similarity. Just not to get confused. Okay, determine if the triangles are similar. If so, tell why and write the similarity statement and similarity ratio. Okay, so for this first one, we know 2 sides for sure because they give us numbers on this side and on this side. And then we also know angle J because these 2 triangles share angle J. So if we have anything at all, it's gonna be SAS because that's the 2 angle, or that's 1 angle and 2 sides, and the angle is included. Now, be really careful here because let's do small over big. So small would be 2 over big, which would be 2 plus 4, which would be 6. Over here will be small over big, which would be 3 over 3 plus 6, which would be 9. So are those 2 proportional? And I'm going to say yes because of SAS. Similarity statement, I'm going to say triangle JKL is similar to triangle JMN. And the similarity ratio, once I simplify this fraction, would be 1/3. Remember, if I'm going too fast, you can always pause me. This next one was a little bit more confusing because they shared a side. So what I ended up doing was I actually pulled this triangle off. PQR 4, 4, 6. And I pretended that it wasn't even there. So I just pretended I had 2 triangles. So I have 3 sides. So if it's going to be anything, it's going to be SSS. So I put 4 over 6 and 4 over 6. And then 6 over 9. Because remember, you put small over big, small over small, small over small, big over big. Since 2 of our sides are the same, 2 of our sides are the same. So are those 3 the same? And they all reduce to 2/3. So our similarity ratio ends up being 2/3. So yes, this is similar by SSS similarity. Sorry, this should be SSS similarity, SAS similarity. So I'm going to say triangle PQR is similar to triangle PRS by SSS similarity, and the similarity ratio is 2/3. All right, so this one, they give us no sides. So this one's obviously, if anything, it's gonna be angle-angle similarity. But in order to do that, we need to check either this angle or this angle to see if they have 2 in common. So let's go ahead and do that. 180 minus 52 plus 81, and that gives us 47. Okay, good. So 47 degrees, which is this angle right here. So we've got yes by angle similarity. So we don't know a similarity ratio because we don't know the sides. So we're just gonna skip that. So we know triangle ABC is similar to triangle FGH by angle similarity. All right, last but not least, this one is the easiest one probably. Again, we don't know any of the sides, so if this is gonna be anything, it's gonna be angle similarity. Remember, this angle has to be right as well. So we know that angle S is right angle, and then angle T is congruent to angle P. So we do in fact have 2 right angles, or 2 congruent angles. So we have enough to say angle. We don't know the similarity ratio because we're not given any of the sides. So triangle TSQ is congruent to triangle PSR. And remember, it does matter how you list them. I did TSQ just because it was easy to see T and then the right angle and then the non-marked angle. And then PSR, the S should be in the same position no matter how you listed it. Okay? So that's it for the notes. So you should be doing this worksheet and this worksheet for your assignment, which is due on